Okay, we've looked at the sum of areas when you add them together. Now we're going to look at the difference of two areas when you find one and minus another one. So again, let's draw our curve. And we've got the curve y equals x squared, which is a parabola. And the line y equals x plus 2, which is a straight line cutting through there at 2. So find the area enclosed. So I'm going to do that in blue. So that's just the area between those two curves. So when you've got an area like this, that's entirely between two curves, it's going from this point here, which we need to find, to that point, then we minus the two areas. So essentially what we're doing is finding that area under the line y equals x plus 2, and then we're finding this area underneath y equals x squared, and we minus the 2 to give the required blue area here. Now that's if there's no points or sharp bits in it, which there isn't. Like in that sum of areas, it came to the point. If it looks like that, then you've got to split it up. But in this one, it's just a straight area. Okay, so we'll start doing the calculations. First, what we've got to do though is find where these two curves meet by simultaneous equations. So these are the two curves we've got. So by simultaneous equations, we end up, if we put everything on the left-hand side, with a quadratic, which we need to solve, and we'll get 2 points out of it, which are our 2x values. And do we need the y values? No, we don't. We're only worried about the x values here. So, excuse me, that would be a minus 2 and a plus 1. So therefore x equals minus 1 and 2. So if I quickly draw it again, that's the point minus 1, and that's the point 2. So we're finding the area between the two of those, and it's a subtraction. So it's from 2 to minus 1. Now it's important you put them in brackets, just in case the minuses change or the signs, which it's not going to do in this case. So what we're doing is, the curve on the top goes first. So in this case, it's x plus 2 minus, and now we can set up another integral, and they should both have a dx after them. Okay, we can set up another integral, but the laws of integration say that that's the same as saying from 2 to minus 1 of x plus 2 minus x squared dx. We don't need to do two separate integrals. Okay, so the minus in this case, it's only applied to one term, so the brackets aren't needed. And then we integrate. So it's x squared on 2 plus 2x minus x cubed on 3 from 2 to minus 1. Now what if in a test or a question you mixed up the fact that that was on the top and this one's on the bottom? No drama, you'll get a negative answer, in which case you just go back and put absolute values on the whole thing and just switch it around, because we know areas can't be negative. So that is, we might actually do this on the next page. So that equals, we'll sub in 2 first, so it's 2 squared on 2 plus 2 by 2, 2 cubed on 3, minus, and now be careful of the minuses. It's minus 1 all squared, so that's a half, we can put that one in, plus 2 to the minus 1, minus 1 cubed on 3. Careful of that one there. So That's 4 on 2 plus 4 minus 8 on 3. So 3 minus a half minus 2 minus, so that's taking care of that minus, and then the actual fraction is a minus as well. So we'll put that in brackets, minus a third. Never forgetting those two minuses don't cancel out because BIMDAS says you've got to do your indices first. So it's 2 plus 4 minus 8 on 3 minus a half minus 2 plus a third. And then you pop that into the calculator and get a grand total of 27 on 6 units squared. Okay, so just think about it. I'll just do it in here. If you had it the other way round, then you'd be getting this bracket first minus this bracket. So you'd be getting a half minus 2 plus a third minus 2 plus 4 minus 8 on 3, which gives you, if you put that on the calculator, minus 27 on 6. So straight away you get a minus, you know it's area, and you can't have that. So you just go and pop absolute values, along your whole sum, such that at the end you'd have a plus 27 on 6.